Hi everyone. So today we're going to be taking a look at finding the area of rectangles that involve quadratic equations. So the past 2 days you took a look at area of a rectangle as well as area of a parallelogram. I hope that most of that was familiar to you from either seeing it in Algebra 1 or maybe seeing it in middle school. What's going to be slightly different today is we're going to involve quadratic equations. Now you might be thinking, well, what's the point of having a quadratic equation with the area of a rectangle? You just measure the length, measure the width, multiply them, that's your area. Well, there are times where you might have certain dimensions for a rectangle and you want to increase them by a uniform length. So that uniform length that you would be adding to both the length and the width would be x. So it turns your normal rectangle with numerical dimensions into linear binomials. Then when you have those linear binomials, when you go to multiply them, it winds up actually being a quadratic, which you then have to solve to figure out what the new dimensions are going to be. This happens when if you're gardening or if there's something that you want to increase the area by a certain amount. So if you're trying to increase the area of a garden by 100 square yards, you would want to do that uniformly to fit the space properly, or else you're just going to be increasing the length or only increasing the width. So the way that we're going to do that is we're going to start by drawing and labeling a picture. Now, when you draw or label this picture, it's going to be an arbitrary rectangle. It doesn't have to be perfect. It doesn't have to necessarily have a longer length than width or a longer width than length. That doesn't matter. The reason we're labeling the picture is just to give us a visual of what this situation that's being described looks like. The second step is to set up an equation using the given dimensions and the given area. So the equation that you're going to be using, we're dealing with area of a rectangle, so it's going to be the area of a rectangle. So area is equal to base times height, or what you might have seen as area is equal to length times width. These are the same equation. However you label your rectangle is totally fine. After you do that, you want to solve the equation by setting it equal to 0. Now, the reason that we're setting equal to 0 here is because we're going to be dealing with quadratic equations. If it happened to be a linear equation, which I believe you saw one or two of those on Monday or on Tuesday when you looked at rectangles, you wouldn't have to set it equal to 0. You can just solve using linear methods. Here, since we're solving a quadratic, we're going to have to set it equal to 0 in order to factor. Now, what you're going to notice is after you factor, when you go to solve, you're most likely going to get a positive solution and a negative solution, or what we like to call it, an extraneous solution. Now, the reason the solution's extraneous here is because we're dealing with side lengths of a figure, and we can't have negative side lengths. When you get to Algebra 2 next year, a negative solution isn't necessarily an extraneous solution. You'll talk about other extraneous solutions in Algebra 2. So here, just make sure that you plug it back in, make sure you don't have any negative side lengths, and then figure out what the dimensions are. All right, so let's take a look at number 1. So number 1 says the width of a rectangle is 3 centimeters less than the length. If the area of the rectangle is 10 centimeters squared, find the length and the width. So the first thing we want to do is draw a rectangle. So again, I'm just drawing an arbitrary rectangle. I know that my area is 10 centimeters squared. And I know that my width is 3 centimeters less than my length. So my length is x, my width is x minus 3. And then I can set up my equation. So I have a is equal to length times width. Now, what you might notice is I used x for my length and then x minus 3 for my width. You could choose any variable that you want. I'm just choosing x because I think it's easiest to have the same variable and set it up that way. So then we're going to substitute in the information that we have. So our area is 10. Our length is x. Our width is x minus 3. So now what you might notice is I mentioned that you might have to FOIL. In this case, we're only going to have to distribute because we only have one binomial and a monomial. What you'll see in example 3, we have 2 binomials, so we will have to FOIL and then factor and solve. Okay, so we have 10 is equal to x squared minus 3x. And we see we have a nice quadratic equation here with a linear term, so we have to set it equal to 0. We have 0 is equal to x squared minus 3x minus 10. And we know two numbers that multiply to negative 10 that adds a negative 3. That's going to be x minus 5, x plus 2, which tells us that x is going to be equal to positive 5 and negative 2. Now again, because we're dealing with side lengths of a rectangle, we do have to check for extraneous solutions. So if we plug in 5, that'll be positive here. 5 minus 3 is 2. That'll work as well. So 5 is a possible solution. Plug in negative 2. That makes our length a negative. So negative 2 does not work, meaning that our dimensions are a length of 5 centimeters. And then our width is 5 minus 3, which is 2 centimeters. Okay, moving on to number 2. So for number 2, it says the length of a rectangle is 4 feet greater than the width. Okay, so let's start by drawing a rectangle because this one's a little bit weird. There's a lot being described here. So the length of a rectangle is 4 feet greater than the width. So I'm going to call my width x. And that means my length is x plus 4. What you might notice here is we're not given an area. So we're actually going to start off by multiplying these. So x times x plus 4 gives us an area of x squared plus 4x. Okay. Now, you might say, oh, well, if we just set this up as x squared plus 4x is equal to x times x plus 4, you're going to get 0 equals 0 when you solve. That doesn't make sense. Well, that's because we're trying to increase the area and we're trying to increase the dimensions. So this is one of those examples that I was talking about, that if you wanted to increase the area of your rectangle by a specific amount and you wanted to increase the dimensions by an exact amount as well, this is where quadratics would come into play. So we're told if each dimension is increased by 3, so we add 3, then the new area will be 33 square feet larger. So we're going to have to add 33 to our area. So the new object or the new rectangle is going to have a length of x plus 7 and a width of x plus 3. And then an area of x squared plus 4x plus 33. So now what we need to do is set up an equation in order to figure out what x is. So we know that our area is equal to the length times the width. Our area is x squared plus 4x plus 33. Our length is x plus 7. Our width is x plus 3. And we notice that we have two binomials here, so we're going to have to FOIL. So we have x squared plus 4x plus 33 is equal to, when we FOIL this, we get x squared. X times 3 is 3x. 7 times x is 7x. 7 times 3 is 21. So we have x squared plus 4x plus 33 is equal to x squared plus 10x plus 21. Now, what you notice here is we have an x squared on both sides of the equation, so that's going to cancel. And now we have a linear equation. We have 4x plus 33 is equal to 10x plus 21. I'm going to subtract 4x and also subtract 21. So I get 12 is equal to 6x. And I get that x is equal to 2. Now you might be saying, oh, well, Mr. Clark, you said that we were going to be dealing with quadratics. We kind of had quadratics here. Up here, we had an x squared on both sides of the equation. This is known as a pseudo-quadratic. The reason it's a pseudo-quadratic is it looks like a quadratic equation. However, because there's an x squared on both sides of the equation, that's going to be able to cancel, and it winds up actually being a linear equation. So that's where we get x equals 2, which is why we only have one solution. Now we're asked to find the dimensions of the original rectangle. Well, remember the dimensions were x by x plus 4. meaning that our length was 2 plus 4, which is 6 feet, and our width was 2 feet. Okay, moving on to our final example. Now this one's going to be a little bit tougher. So here we're told a school is building a rectangular sandbox that has an area of 63 square yards. The sandbox has the following dimensions: x plus 2 by 2x minus 1. Determine algebraically the dimensions of the sandbox. Okay, so again, our sandbox. And again, your picture is arbitrary, so I'm just going to call this x plus 2 by 2x minus 1. My area is 63 yards squared. So we're going to jump right into our equation, which is going to be 63 is equal to the length, which is x plus 2, times the width, 2x minus 1. Okay, so we have 63 is equal to, we have to FOIL here, so we get 2x squared minus x plus 4x minus 2. Combine like terms, we have 63 is equal to 2x squared plus 3x minus 2. We're going to have to subtract 63, so we have 0 is equal to 2x squared plus 3x minus 65. And here we're going to have to factor using the AC method. So we're going to say 2 times negative 65 is negative 130. Our b value is 3. We need two numbers and multiply to negative 130 that add to 3. So that's going to be positive 13, negative 10. So 0 is equal to 2x squared minus 10x plus 13x minus 65. Then we're going to factor by grouping. So we have 0 is equal to 2x times x minus 5. Factor out of 13. And we have x minus 5. So we wind up getting the factored form of this equation, which is going to be 2x plus 13 times x minus 5 is equal to 0. So we get x is equal to negative 13 over 2, and x is equal to 5. If we go to plug in negative 13 over 2, that'll give us a negative width. So we get that x is equal to 5. Meaning that our length, which was x plus 2, 5 plus 2 is going to give us 7. So our length is going to be 7 yards. And our width, 2x minus 1, 2 times 5 is 10, minus 1 is 9. So our width is 9 yards. All right, and that is it for today. Please complete questions, 9 through 12 on the weekly assignment, and reach out if you have any questions. Have a great day, everyone.